And welcome students to our final review lesson. We're going to be talking about arrays. So let's go ahead and get started by recalling that an array is a collection of types such as int, char, double, string, or other class types. When we create an array, we generally use the following format. Type array name equals new type array length, where type is the primitive or the class type. Array name is the name of your array. Array length is the length of the array. So for example, char array letter equals new char 5. Now, obviously, we can also define an array size, and we just saw that in the example I just gave. Recall, you can either explicitly define the array size, or you can use a variable. So int array number equals new int 5. It's explicitly defined with a number. I can also do that with a variable. So let's say array size equals 5, int array number equals new int array size. Right? And of course, the advantage of using a variable right here is that you could use keyboard input. Like, please enter the size of the array. You can set the array size to, keyboard.nextInt, for example. All right, let's talk about initializing array elements. You can explicitly define array elements. Remember that arrays start at index of 0, not 1. We saw this when we talked about strings, for example, string.length. Because if you start at 1, it's going to change your actual values from if you had started at 0. Now, obviously, array 0 is always going to be the value of the first index. So if I want the first value, let's say equal 3, I could write array 0 equals 3. And this can be done for the rest of the elements as well. Now, we also use this using a variable and a loop in order to automatically fill the array. So if we want to do that, here's a quick example. Double score equals double 5 into index. System out of print line, enter press scores. Score 0 equals keyboard.next double. Max score 0. So not really, max of course is just keeping track of the max value here. We're not really going to worry about it because what we really want to focus on is this right here. For index equals 1, index is less than 5, index plus plus, score of index is equal to keyboard.next double. Okay. Let's go ahead and look at using array.length. For this example, we use a variable or a number to define the end of the array. However, sometimes this can cause issues, so a better approach is to use array.length. Array.length will simply return the length value of the array. So here's the exact same program that we just saw, except instead of having this be explicitly defined as a number value, we are now using array.length. All right, let's look at printing an array. You can't just output an array, because if you just do like system.println with the name of your array, it's going to give you undesirable output, usually because it's referencing memory and stuff like that. Instead, you should output the index value, system.println array of index. Often we want to output the entire array as well, so we can use that using a for loop. So system.println, the scores are for int index equals 0, index is less than score.length, index plus plus, system.println score.length. One thing also you might have noticed, back here with these examples, this one is starting at index of 1. So in this case, your first 0, where your first index is, that was defined here. Okay, with score 0. And that's the reason why this one started 1. If we didn't have this line of code right here, then this array would have to start at 0 as well. All right, if we look at the printing example here, we're starting at 0 because there's nothing to, we're not explicitly printing out that one beforehand. All right, so here, this is generally what you're going to do when you're going to fill, or if you're going to print, you're always going to start index at 0. All right, and here I'll say print line of score of index. All right, some notes about arrays. Recall that arrays can be used as parameters of methods. If you're using a partially filled array, it will require a little bit of extra work to keep track of how much the array is used, and it cannot reference any index variable that does not have a meaningful value. In fact, I believe we had a whole class called partially filled array that we used for that example. All right, let's talk about multidimensional arrays. Recall you create a multidimensional array similar to that of a normal array. So here I have char array page equals new char 30 100. Now note, you are not just limited to 2 dimensions. You could technically have a 3-dimensional array, a 4th-dimensional array, whatever. So you can make as many array dimensions as you want. The easy way to think about this is that an array, a multidimensional array, excuse me, is an array of arrays. Because what it is that you have your array with, you look at one array element, and inside that multidimensional array, inside that one element, so there's going to be another array. We had a good visual example back in Programming 1 of how this works. All right, now with multidimensional arrays, they're often filled with a nested for loop. So here's our quick example of the nested for loop. So the following fills an array with the char A. So here our page is new char 3100, just like we saw before. For row equals 0, row is less than page length row plus plus. For column equals 0, column is less than page of row dot length. There's no answer, we're using page of row. Column plus plus, page row column equals A. Simple. Now, of course, you can substitute this right in here with any other kind of command like a system out of print line, please enter an input, that sort of thing. You can do that all in there. Now, sorting is our final topic we're going to talk about. Recall that we discussed two different types of sorts in programming 1. The first was the bubble sort, which used nested for loops in order to sort through each element of the array. And the second thing was a selection sort, which used methods and for loops to sort through the array. Now, if you recall, a bubble sort was less efficient than that of a selection sort. And the bigger your data set was, the more prominent you saw the difference, especially if your number set was a lot more varied, like in its order. Like if the numbers were fairly well organized, bubble sort did okay. But if they were not sorted very well, they're just kind of mixed around randomly, the bubble sort quickly became very inefficient. Now, we'll eventually discuss other algorithms and techniques as we advance in this course. One thing I'm going to say is that we will talk about some things such as like lists and stuff like that that we'll get into that are going to make us be able to develop more efficient algorithms. Yeah, so it's going to be a fun time. Let's wrap up this review here. You got one final lab, and then you're going to have your assessment piece coming up to just kind of make sure that you are good to go with your programming 1 concepts. And then we'll be jumping into programming 2 in no time, folks. So until then.